Hello friends, we're going to take a look at solving trig equations part 2, and you can see some really important questions that would be helpful to solidify your understanding. And don't forget to go forward of 1 to 11. These are key questions that let you know where you should be at after this lesson. So here we go. So this is solving equations part 2. All right, so you can see by the look on this woman's face that we are going to need to do some problem solving. She's deep in thought and lots of ideas swirling around her mind, and we're going to need to make these connections as well. And so today's lesson is solving trig equations without technology. So you don't need your calculator, but you could certainly use Desmos to confirm your answers and to see the answers from more than one point of view. Okay, so today, these are some of the tricky questions we're going to be looking at. And I think as you look at them, you'll see that they, and you can see how tricky some of these questions are at this point. So I'd assume that most of you would not be sure how to solve these. And so by the end of this lesson and your time here, we should have a pretty good handle on this. Okay, so let's go. So the first thing we need to do is just be aware of what your tools are. Your tools are going to be the special triangles and the waves. Here's our cosine wave, and here's our sine wave. So here's some warm-ups. So if we say solve sine x equals cos x, we're trying to figure out when is sine x and cos x the same, and the waves wouldn't help with an exact answer here. But if you look over here into these two triangles, I notice here that in this isosceles triangle, the sine of the angle would be 1 over root 2, and the cosine of the angle would be 1 over root 2. So the sine and cosine would be the same. So I know that the reference angle here would be 45. And I also know that sine and cos are both positive here, and they're both negative here, which means there's going to be one angle here at 45, and the other one's going to be here with a reference angle is 45. So it's going to be 45 and 225, or pi over 4 and 5 pi over 4. All right, so now let's look at this. Cos x equals 0. Now we're not gonna use these guys, and we're certainly not gonna use the sine wave. Does cosine ever equal 0? Well, of course it does. It equals 0 there and there. So I know that if that's 180, that's 90. That's pi over 2 right there, and that's 3 pi over 2. So there we go again. Alrighty, sine x equals 0. We're going to go back to the waves again, and sine equals 0 in these spots here. And so the solutions would be 0 pi and 2 pi. Okay, and the last one, when does sine x equal 2? This can cause a bit of trouble. So when does sine x equal 2? I'm tempted to go over to a triangle with a 2 in it, so maybe this one. But sine equals opposite over hypotenuse. So, and the hypotenuse is 2. So I don't see that one helping out. Now I'm going to go over the sine wave and look for when does sine x equals 2? Well, here's 2 all the way up there. Wait a second, okay, so we can see graphically that there's no solution, but we know there's no solution for another reason. If sine is opposite over hypotenuse, what we're saying is that the opposite is 2 and the hypotenuse is 1, and that's a triangle I don't know how to draw. So we're going to go ahead and say there's no solution for this one, which is the truth. So x equals no solution, undefined. All right, now what we're going to do is we're going to go back and do a little review. So we're going to do a little review here. This one says determine the exact solution without technology over the set of real numbers. Okay, so when I see 5 cos x plus 4 equals cos x plus 2, initially you might say, I'm just not sure what to do. But if this said 5a plus 4 equals a plus 2, wouldn't you just subtract a from both sides? So you'd have 4a plus 4 equals 2, and then you take 4 to the other side, subtract 4 from both sides, and divide by 4. Well, that's exactly what we're going to do here. Or put it this way, if this is the square root of a and the square root of a, we call these like terms. So that's exactly what these are. So what I'm going to do is I'm going to subtract cos x from both sides. Let's see if that, so that's what I did here. So I subtracted cos x from both sides, giving me 4 cos x, and then 2 subtract 4 is negative 2. And then at this level here, I just divided everything by 4, and you're going to get cos x equals to negative 1/2. I can see that my next step would be to use this triangle here. And remember, that cosine equals adjacent over hypotenuse. And if that's the truth, then that means that the 1 is the adjacent side, which means 60 is the reference angle. So 60 is the reference angle, but be careful. Because it's negative, we know which quadrants it's in. So cosine is negative in this quadrant, which means that the reference angle here would be 60, leaving 120 on this side. So one of the angles is going to be 120. The other angle is going to be in this quadrant right here, and its reference angle will be 60. So that would be 180 plus 60 for 240. So that's how we came up with this. So we knew it was being quadrant 2 and quadrant 3, and we'd state the solution. There's my 120, and there's my 240, and notice that we've added 2 pi n, and I know that because the period for cos x is 2 pi, and we're going to be adding whole multiples of 2 pi, so 1, 2, 3, 4, and then this nei, it's more formally known as n as an element of z, which stands for integers. This is my own notation, and that should be a different symbol. It should be the E for element. N is an element of the integers. Anyhow, that's what it looks like now. If you weren't asked to graph it, but if we did graph it, here's what we see. There's the first solution, there's the second one, and notice the gap between here and here is 2 pi, and here's the gap between there and there is 2 pi, and so that's what it looks like graphically. So what I'm trying to do is show my solutions in many ways. The question did not ask for that. It actually asked for no technology, but your ability to solve this with algebra and with technology shows your flexibility in solving problems. All right, so that's the warm-up. Now let's get in. So today we're going to be doing a little bit of factoring. Your factoring skills are important. So I'm going to ask you to pause the video right now and make sure you can do each of these. So I'm going to, when you come back, I'll go over this if you need it. But if you know how to solve this, then move on. Okay. So here's how we do this. We are going to add 2x squared to both sides, like so. And so then we're going to have 4x squared equals 1. I'm going to divide everything by 4, so x squared equals 1/4. Now I'm going to square root it, so x is going to equal plus and minus the square root of 1/4. And another way of writing that is plus minus 1 over 2, because the square root of 1 is 1 and the square root of 4 is 2. So that's the first piece of review, and the solutions would be plus and minus a half. Okay, so then this next one, this one also can cause trouble, so please try it first. This is a review from grade 10 and 11, so this is a skill that you have, and so if you already know how to do it, you can move on. So pause the video and then check in with me. Okay, so this one, remember, we're always going to look to start to factor right off the bat or take out a GCF, and in this case the GCF would be x, and so that would be 2x plus 1 equals 0. And so if we're wondering what the solutions are, we're going, well, what would x have to be so that when it multiplies it's equal to 0? Well, of course 0. And in this guy here, we're saying when 2x plus 1, when does it equal 0? And so I just solve that little equation here, and x equals -1, so x equals -1/2. So the solutions here would be 0 and -1/2. And so when we take a look, we got it again. Okay, and here's the last one. So this is solve again, and this is just do you know how to factor? There's a number of ways of factoring. One way, because these numbers are pretty straightforward, is I could just sort of guess and check. I kind of like guessing and checking myself on this one. So I'm going to go with 2, an x, and then a 2 and a 1. So 2 times 1 is 2. And then on the other side, I'm going to need a 3. And I also need a 5 to come out in the addition. So I'm going to go with 3 there. So I'm going to get a 6. And it has to be negative, so it's going to be negative. So now I've got the negative 6x, and then I'm going to add 1 to it, and then I'm just going to check. So there's my 2x squared, there's my -3 multiplied to -3, and there's my added to -6 and added 1. So we got that. There are other techniques, of course. One that you're familiar with is probably decomposition, which is often done. So I'll just do that real quick here. So we'd be looking for two numbers that multiply to -6 and add to -5, and those numbers are 6 and 1, and so that would have to be a -6 right there. And so then what we do is we decompose it. I'm going to use a different color here so we don't get confused. It's going to be 2x squared minus 6x plus x minus 3. And then what we're going to do is we're going to group. So I'm going to take out anything out of that can come out. So that would be 2x, leaving me with x minus 3. And you can see here that nothing, only a 1 comes out of that. So I'm going to take a 1 out, leave me with x minus 3. And then what I'm going to do is notice that here there's two terms, and I'm going to take out the 2x, the x minus 3 out of both. So when I do that, I'm going to get an x minus 3. And I'm going to get a 2x is left behind, as is the 1, and then we're at other places. There's a lot of different ways of factoring. That's 2. You can try the box. There's just so many ways of factoring, and there you go. So that's a warm up. Okay, so that's reviewing a skill that you have known in the past, and now we're going to go and apply it. So here we go. So this one says solve 2 sine squared x equals -2 sine squared x plus 1. So what I want you to do is turn off the video, give it your best go, and then check in. And you could use, there are some hints. There are some hints here for you if you need them. Okay. So I am going to pause the video, and you pause the video, and let's get back in just a sec. Okay. All right. Welcome back. So first thing we need to do here is try to isolate sine x squared. Notice that there's no sine x term, so that just tells me all I'm going to do here is I'm going to add 2 sine squared to both sides, which would leave me with 4 sine squared x equals 1. I'm going to divide both sides by 4. So sine squared x equals 1/4. Okay, I've isolated that. Now what I want to do is square root that. So now I'm going to have sine x equals, the square root of that is going to be plus or minus, because it could be, the sign could be positive or negative. When you square it, you're going to get the positive 1/4. It's going to be the square root of 1/4, which simplifies to plus or minus 1/2. Okay, so now I've isolated the sine x. So now what I need to do is figure out what's the reference angle, and to do that I need my triangle. Here's my 60. Here's my 30. This is root 3. This is, I mixed that up badly. That would be 30. That would be 60. That looks better. Okay, so this would be 1. This would be root 3. And this would be 2. Okay, so the opposite side here is 1. So if the opposite side is 1, that must mean that the reference angle is 30. So the reference angle is 30 degrees. Then we have to check quadrants. I know that sine is positive in the top 2 and negative in the second 2. So this one is looking at, when sine x equals, when sine x is positive, so positive 1/2, we're going to be in the top 2 quadrants at 30, and remember the reference angle will be the same. And it's not drawing for some reason. My pen isn't, for some reason, oh, there it is. Having some pen issues here. Okay, so anyway, it would be 30. There's my 30. And then we'd have in the second quadrant, when it's positive, we have 150. So here's my 150 here. And then in the third and fourth quadrant, we would have 30 plus 180 would be 210. And then it would be 360 minus 30 for 330. So there you go. Okay, let's try the next challenge. Okay, so in this next challenge, we need to be able to factor this sucker. And so there's a lot of ways of factoring it. What some people will do is they'll kind of see it like 2a squared minus 5a minus 3 equals 0. And it looks like my pen is going to be giving us issues this whole time here. So we'll see how this goes. So the first thing you want to do is factor it, okay? And so I trust that you know how to factor by this point. So basically it's going to look like 2 cos, I'm going to say x just because it's a bit easier with the pen that I'm using, and cos x minus 3 plus 1. Okay, this is not, and that's all equal to 0. Alrighty, so then we're going to isolate, and so we've got two possibilities here. Either 2 cos x plus 1 equals 0, or cos x minus 3 equals 0. Okay, and so this top one is going to turn into cos x equals negative 1/2. And this one right here is going to turn into cos x equals 3. Really having trouble with the pen here, guys. So, okay. So a couple things. When does cos x equal 3? Well, we know that cosine equals adjacent over hypotenuse. And right now we have a problem here because cos x has an adjacent side that's 3 and the hypotenuse is 1, which tells me there's no solution for this. Another way of thinking about this was if you do a quick sketch of the cosine wave. We know that the cosine wave has a maximum height at 1, and so 3 is up here, so there's just no solution to that. So then what we're going to do with this guy, cos x equals negative 1/2, is we're going to go and check our special triangles, and we're going to figure out what the reference angle is, and then we're going to determine which quadrants it is in. Okay, so we know that, yeah, I'm doing this all with a mouse, so this is just, it's so slow. Okay, so here's our special triangle, and we know that the adjacent side is 1, therefore 60 is the reference angle. We know that cosine is negative, which means that it must be in quadrant 2 and quadrant 3, and so therefore that's why we know, and the reference angle is 60, so that's why we know that the angles are going to be 120 and 240, or 2 pi over 3 and 4 pi over 3. Okay, let's try the next one. Okay, so this one is determine the exact solution over the set of real numbers. So again, here what we're going to want to do is factor this. Oh gosh, we're having, it's responding now, that's better. Again, there's so many ways of factoring. I'm going to test my luck at guessing and checking because these numbers look pretty easy to me. So I'm going to go 2 sine x. This is not a good notation, but because of the pen, I'm just going to do this. Okay, so this is going to be 1 sine x. Please don't do this in your work. It will not be accepted. Okay, so then we're going to go minus 10. And I'm just sort of, this gives me a, oh, is this what I want to do? Oh, wait a second, this might not work for me. Okay, we're going to try this again. So I'm going to look for a couple numbers here that multiply to negative 20 and add to 19. So to me, that looks like 1 and 20. And the 1 has to be negative. Okay, so I am going to, what am I going to do this time? Yeah, I'll do decomposition. I don't like the method, but it's what I'm going to do. Okay, so here we go. So I'm going to go 2 sine squared x plus 20 sine x minus sine x minus 10 equals 0. And so then I'm just going to take out common factors. So I'm going to take out a 2 sine x, leaving me behind sine x plus 10x, no, plus 10, bracket. Then I'm going to take out a minus 1, leave me with sine x plus 10. This is, pen is not working again, friends, so sorry about this. Let's see if we can clean that up. So this is the sine x, this is the plus. Okay, so now we're going to take out the sine x plus 10. Sine x plus 10, bracket, and then leaving me behind with 2 sine x minus 1, okay, equals 0. So we're basically wondering, when does this thing equal 0 and when does this thing equal 0? We know that this one here, we know that the sine x plus 10 will have no solution, because we're going to have a situation where the opposite side here is bigger than the opposite side is going to be bigger than the hypotenuse, so there's just no solution to that. With 2 sine x minus 1, we're going to have sine x equals to 1/2, which is back to our special triangles, and the reference angle there would be 30, because the reference angle would be 30 because the opposite side is 1. So if it's 1, there's my 30, there's my root 3, and sine is positive in the first and second quadrant. So the first and second quadrant would be up here. And again, friends, I'm so sorry, my pen is not operating, so it's difficult to explain in the way I'd like. But we know that the reference angle would be 30, so it would be, one of the angles would be 30, and the other one would be in the second quadrant, and the reference angle there would be 30, so it would be 30 and 150. And it's set over the set of real numbers, so this we could say 30 and 150 are the solutions, but then what we want to do is add, we're going to add 360n to both of these. We could also do this with 2 pi. It did not say how to leave our answer, whether in degrees or radians. Oops, what happened there? Okay, so anyway, in that last one, let's see, okay, good. So it would have been 330 and 360, n, where n is an element of the integers, and z is more formally used there. I just use it because I stands for integers, and that's sort of my own notation. So there you go. We could have just as easily said pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. Okay, so there you go. Okay, is this our last challenge? Which is not. Okay. So this challenges can be quite tricky. The first thing we're going to do here is pause the video, and you're going to try it so that you know how hard this is. But basically what we're going to do is we're going to factor. So we're going to take out a 4 cos x, leaving us behind cos x minus sine x equals 0. And so either, there are two options here, either 4 cos x equals 0, and in that case, we're like, when does cos x equal 0? Or cos x equals 0. Now here's my wave, and I'm wondering if I pulled out, let's see. Yeah, I'm gonna look at this if I can here. we can just see that cos x equals 0 at the x-intercepts. So that's going to be a pi over 2 and 3 pi over 2. So you'll notice in the solution here, it's pi over 2 plus pi n, because the gap between these points is pi. And so that's why it's pi and not 2 pi n. Okay, so that's the first part. And I hope that helped. Now the next part is remember we had for cos x, I'm going to do this again, we'll have cos x minus sine x equals 0. So then what we're saying is, when does cos x equal sine x? So this is, oops, not equal to 0. When does cos x equal to sine x? I know that in this special triangle here, that the sine of 45 and the cos of 45 are equal. So that means that the reference angle here is going to be 45 degrees, or pi over 4 radians. We also know that sine and cosine are positive in the first quadrant together, and they're negative in the second quadrant together. So one of the angles would be 45, and the other one would be 180 away at 225. So that's why you have a solution here of pi over 4, or 45, plus 180 degrees, or pi radians. So here's our solution, and many of us will find this a pretty tricky question. So hope that that video clip helped. And of course, it's always good, it's not a bad idea to check this solution on Desmos, just so that you can see that it does in fact line up, and that we can see our solutions in many ways. So we're connecting technology and our algebra to solve problems. Okay, so this is the last one, and this can cause troubles once again. I mean, it looks simple enough, but cos 3x equals root 3 over 2. So what I want you to do is turn off the video again and give this a go. Like get it, or get a little frustrated, or get a little confused, so that when I talk about it, you can see what it is that you were confused by, and then we'll fill in that gap. Okay, first step in this problem would be to recognize that that's looking pretty familiar. Those numbers to me are looking pretty familiar. And so I'm going to draw my special triangle, because I know that it has a root 3, it has a 1, and it has a 2. And so I know that that would be 60, and that would be 1. I know that cosine is adjacent over hypotenuse. And so that tells me that, oops, that should be 30. That's telling me that 30 is the reference angle here. Okay, so one way of looking at this would be to say, I know that the cos of 30 equals root 3 over 2. Okay, so that must mean that 3x equals 30. So that means that x must equal 10 degrees. Okay. I also know that cosine is positive in the first quadrant and the second quadrant. And so I also know that the cosine of 330 also equals root 3 over 2. Also equals root 3 over 2. So that must mean that 3x equals 330. Which means that 3x equals 330, so x must equal 110. Okay, so here we go. So what we have right now is, we know that usually the solution would be at pi over 6. Oh my goodness, this is so slow again. So if I divide that by 3, we're going to get pi over 18. Because we divided that by 3, or multiplied it by 1/3. And then we also have pi over 11 pi over 6, which is 330. So this would be 11 pi over 18. And now what I need to do for both of these is add the period. Okay, so here we are. We're going to add the period here, and my pen isn't working for some reason. So here we go. So we're going to add the period, and in this case, the period is not 2 pi, but 2 pi divided by 3. And don't forget the n, and don't forget the n as an element of the integers. Okay, so there you go. And this is very messy, and the pen has really let me down today. But I hope that this gave you something to think about and hold on to. And so there you go. So that would be the solution there. And I'm going to clear the screen. And all right. So what we did is we as you can see, is that we got our pi over 6 and our 11 pi over 6. We divided them both by 3, giving us the 18. And here's our solution. So I hope that helps. Obviously, it was a really tricky lesson, and there's a lot to think about there, and I hope this helps.